Hi, I'm Victor, the main organizer of the Full Stack Flutter conference. On this channel we publish the best talks from the conference every week throughout the year, so make sure to subscribe so you don't miss out. I'm also the founder of ServerPod, so if you want to build your backend in Dart, make sure to check that out too. Dillon Nys wrote the Amplify Flutter framework for AWS. Now he's the founder of Celest. He will talk about how he's building a cloud platform for Flutter. Let's go!
Hello, and welcome to How to Build a Cloud Platform, and also why. So as I was writing this talk, I realized that this might be an equally important and interesting question, and so I want to start with the why. Why do we need another cloud platform? And then why do I want to spend the rest of my life building one? But first things first, who am I? My name is Dillon, and if you're curious, it's Nys, like the opposite of nephew. I'm 28 years old. I'm a huge Dart and Flutter fan, and I'm currently rebuilding Firebase for Dart. And to tell you why, I can really think of no other way than to tell it exactly as it happened to me. So I've been building Flutter apps for about 6 years now. With my first few, I had no backend knowledge whatsoever. And so I turned to Firebase to solve a lot of the issues that come up there. And I loved it. Everything about it. I thought it was super, super cool. Well, except just there was one thing. I couldn't write my cloud functions in Dart. And this was frustrating, but the time there wasn't much I could do about it. And so fast forward a few years and a few Flutter apps later, and I get my first professional software job working at a company called Medtronic, building this Flutter app. If you can believe it, it had even worse ratings when I joined. But there was one problem. When I joined, this app was experiencing a lot of issues around its authentication. Users were getting constantly logged out. The OAuth server we were using was getting basically DDoSed by the app, and nobody could figure out why. And so me being stubborn, thought this would be a great way to spend my time as a junior Flutter engineer. And so I spent most of my time there fixing issues in our OAuth libraries. Things like race conditions, where the only way to debug it was to keep my phone plugged into Xcode overnight, hoping that the race condition would happen and I had the breakpoint in the right spot that I could debug it in the morning. The fix for that one looked like this. This was a whole PR. Took 2 weeks to do. And pretty quickly, I started to become the subject matter expert on OAuth at the company. And I was hooked. Through this process, I ended up reading every OAuth spec out there. And there's not too many. And they're actually quite easy to read. And very interesting, I thought. And I started to have a lot of fun with this. I actually thought auth was really cool. This was a whole new world for me. In my free time, I went and built my own OAuth server. I wrote the backend in Go, and I had what I was pretty proud of at the time was a pure Dart client that could work on both Flutter and in pure Dart environments. I called this project FTAuth. It's totally open source if you want to go see my old crappy code. And I did a post about it as well. And so it was around this time that I'm getting very interested in auth, very interested in backend. But I want to still write Dart, and so I'm trying to figure out what's next for me. And as luck would have it, AWS posted an opening for the Amplify Flutter team. And I just thought, perfect. This is exactly what I want to be doing. It's the cloud, it's the backend, it's the Flutter, it's the Dart, it's everything. And so I applied, joined, and very first day I'm talking to my boss, and I learned that the library is just a wrapper over their iOS and Android libraries. And so you can imagine the first thing that came out of my mouth was, let's rewrite it in Dart. I can't remember if it was let's rewrite it in Dart or we need to rewrite it in Dart. But either way, eventually he said yes. And then we spent 1.5 years doing exactly that. And this ended up being a very large effort because, other languages could kind of just take for granted a lot of the ecosystem that existed. For example, we needed to go write an AWS SDK for Dart, which had never really been done before, which required translating all of the API specifications, which are written in Smithy, into Dart with this code generator. And you need a code generator because, just to give you a sense of scale, when all was said and done, the AWS SDK was about 10 million lines of generated code. And so, yeah, if you thought your build runner was bad, like, trust me, it gets worse. The worst part is they never let me release this, but if anyone's interested, I'd love to revitalize this project. And there was a lot of other just like random things we needed. So, one of the first things I had to do was write the SIG v4 protocol so that you could actually sign requests to AWS with your AWS credentials. We ran into some pretty hairy stuff with the auth library where we needed to do this password hashing that required a bunch of computation, and it would just stall the main thread. And so I had to come up with this abstraction over both isolates and web workers that, allowed us to work within both realms. I think the result was pretty cool there. And then just a bunch of other random stuff, platform keychain access for the auth library, some SQLite stuff for storage. We basically just spent this year and a half just writing Dart. There wasn't too much Flutter, but it was just a lot of Dart code. And this experience kind of left me with some key takeaways. So the first is just that Dart is awesome. I already knew this coming in, but I got way more conviction about this. I was just having a blast. And that it's actually very capable outside of Flutter. There's this whole world of use cases that Dart can handle. I had this internal tool, CLI tool for managing our mono repo. We had written some GitHub actions that was just Dart compiled to Node.js. It worked seamlessly. We had some Dart servers helping to orchestrate some things, and it was beautiful. I could just work in the same language, the same tool chain across all these different paradigms and environments, and it always just worked for the most part. I just thought that was so cool. And then, the biggest surprise though was that other people were feeling the same way as me. For the longest time, I just thought I was alone in this understanding or belief structure that Dart was awesome. But, as soon as we released the rewrite, customers were going crazy about it. And then they started asking, to use Dart in more places. They wanted, full Lambda support for Dart. They wanted the rest of the AWS SDK. They wanted, container support, all these different use cases that they just wanted to use Dart and they wanted to use it full stack. And, I found this very compelling, and I started to see kind of this bigger picture for how Dart and Flutter could kind of shape the cloud landscape or participate in the cloud landscape. Because in particular, I had been working with a lot of different technologies. I was getting exposed to a lot of things, and it starts to pile up all of the different programming languages and concepts and environments that you need to be constantly not just aware of and familiar with, but also switching between. And as the complexity of your backend grows, it for me was becoming unwieldy because I just wanted Dart. I just want to do everything in Dart, and that's it. I don't everyone else does it wrong. I just want to do Dart. And so, at the time, this grander vision of things didn't quite align with AWS's priorities. So I decided one day that I was going to leave. I had 3 months of savings in the bank, but I was going to do whatever it took to see this vision come to the world because I just had built so much conviction in its power. And so I did what many others do in my position when you have no money and a big idea, and I applied to Y Combinator, which, for those who don't know, is a tech startup incubator. And I roped in a buddy of mine. We called it Tio, and we were going to build the Vercel of Flutter's era. And to my big surprise, a few weeks later, on what was perhaps one of the greatest days of my life, we got accepted. And, we renamed it to Celest. We had this cute little bird cloud, and we were off and running. And there's a bit more to that story. If you're curious, I published the full app that we used, and I was recently on a podcast where I share a lot of that experience. Also happy to answer any questions, but we were off and running. And so that is the why behind Celest. And I hope it was interesting. Hope you found it useful. But if not, I think we can now shift gears and talk about how, the what and the how. And so for the rest of this talk, I want to focus in on this function. And to kind of set the stage, assuming that this function works, I want you to take a second and think about kind of what you would expect to happen if you were to call this function from your Flutter app. This is not a trick question. Intuitively, you may expect that if you were to call this function from your Flutter app, that it would run in the cloud, not on your device, but otherwise should behave almost identically to any other Dart function. You pass in inputs, you get outputs, you can try catch it, you can do all the things that you would normally expect. And this is the insight that really drives Celest, that everything that is relevant to this function's execution, whether it's running locally or anywhere else in the cloud, all of that information is already encapsulated by just the syntax of the language, just by your expressing of the function as you normally write it in Dart. It's all there. And so what do I mean by that? Well, so we have a Dart API here, right? It's got an input. In the case that it's successful, we get a response. And in the case there's errors, we get a different kind of response. And, to put this in the cloud, all we need is to make this into an HTTP API. And the HTTP API, will take an input. It'll have a certain kind of response when things go well, and it'll have a different kind of response when there's an error. So this is the insight, that these are really just representations of the same thing. And if we can just teach a computer this beautiful fact, then we can unlock this whole world of potential use cases for Dart. And so, but this is the tricky part. So how do you teach a computer this insight? And it starts by teaching it how to understand the intent here. And what I mean is, as developers, we can look at this and we can capture all the semantics of this program right off the bat. We see the inputs, we see the outputs, we see that it's async, it's returning a string. All these things we're just instantly capturing. And so when it comes to computer, though, can get a bit more tricky. But luckily for us, the Dart team has done the heavy lifting here. This one's basically a freebie. And we get to use Package Analyzer, which, among many other things, allows you to get a fine-grained representation structure of your Dart program, of any Dart program, in Dart, which is pretty meta and awesome. And it does this through kind of two mechanisms. So it gives you basically two ways to view the same Dart program. You can look at it through the AST model, which gives you a syntactic representation, meaning that word for word, it is trying to represent the source file as it exists. Just whatever is written in there, the AST is translating into, some sort of structure. And then it also provides an element model, which starts to bake in more of the semantics of the language, more of the behavior of the actual Dart language and syntax that may not explicitly be expressed in the source file. And to kind of see this in action real quick, we're going to look at this simpler program. And so for this, the AST representation looks like this, and we can start to see kind of this one-to-one mirroring of the Dart file. We see the class declaration followed by a function declaration, and each one is composed of the actual syntactic words or tokens that build it up. Things like left bracket, right bracket, right? It's just one for one mapping each one of those tokens into a Dart form. And then if we look at the element model, we see a lot of the same information, right? We see that class, hello world, but then we see things like a synthetic constructor, right? And synthetic means just that it's not been explicitly expressed in the Dart code. We didn't write a hello world constructor, but it's there, right? Because the Dart language says it's there. And so we start to be able to understand this Dart program without ever running it. We can start to predict the behavior of it And, for our intention, we can start to predict its intention. What is this trying to express, right? So going back to our function, here's the element model for it. And if we look at this, we can see that it has everything that we need. We've got the name of the function. We can see the @cloud annotation on it. We can see that it has a single input called person of type person, and that at some point, it's going to return a string. And so the second step is to start mapping this to HTTP. And this is where we're going to have to start making some opinions about things. But we're going to do so under the guiding light of a design principle, something that we can always fall back to on how we're thinking about this. And so for us, it's going to be the following: to have sane defaults, right? Because there's a lot of ways you could imagine to translate the semantics of this program into an HTTP call. And so we're going to make some rules. And the goal of these is not to impose these opinions on every use case out there, but instead to create some reasonable defaults that will work in just about every use case. And so these are the rules I came up with. You may come up with different ones, but that's okay. So number one, anytime a function is annotated with @cloud, it's a cloud function. To call the method in the cloud, you're going to use an HTTP post request. The inputs and outputs will be serialized to JSON. Returning a value from the function represents a successful response of 200. Throwing exceptions are serialized and returned as 400 codes. Throwing error types, the same, but we're going to return 500 instead. And then we're going to take the name of the function and the name of the file it's in and combine them to form a URL for this. And that's all we need. We've got every part of the HTTP API spec'd out, mapping back to the Dart function, and in a way that's going to work pretty well for just about any Dart function, which I think is cool. And so what's next? Well, now we got to actually create the thing. So we've got it spec'd out. We've got the idea of what we want to do. Now we just need an HTTP server that's going to listen for requests. And then for each request, it's going to need to deserialize the incoming request. So we said we're using JSON. So it's going to take that JSON body and map it into the input parameters to the function. And it's going to pass it in and run now that function. And then depending on whether it's a success or an error, we're going to serialize it appropriately. And then we're going to respond with the correct status for whatever happened. And so if this sounds familiar, chances are you've done some backend work, because this is a very common pattern to do when you're talking about communicating information over the wire and establishing a protocol. And it can be a lot to do this by hand for every function you have, or try to do it generically. And so I don't want to do that. I don't want to write that code. Chances are you don't either. And so what we're going to do instead is actually just teach the computer how to do this repeatedly for any time. And we're going to code generate it. And the beauty of this and the power of code generation is just that we just have to teach the computer once the heuristics of how we're thinking about creating the Dart code for this. And then it can scale up from there to any project size, which is really, really cool. And I know there's mixed opinions in the community about code generation. I've written a lot of code generators myself. I can completely empathize. The tooling doesn't always feel like it's at the level it needs to be at. But I think, those are just opportunities for us to contribute, because, if we really see the power in it, then it's worthwhile. So I'm going to suggest that the design principle for this one is just to embrace code generation. And so when I need to do code generation, which I happen to do a lot of, I almost always will turn to one of the amazing tools we do have, which is the code builder package by the Dart team, which is really cool. It lets you kind of express the Dart code you would like to generate in a declarative way in this kind of meta language where you're declaring classes and methods and fields, and then it will just spit out, relatively good looking Dart code. And so for our function, this is kind of what it ends up looking like for my code generator. And this shouldn't look too scary, maybe outside the prefixes. All we're doing really is, at the start, we're kind of establishing some serializers so that we understand how to translate both our person input and the exception type we had to and from JSON. And then for every request from there, we're going to deserialize the body into the person object, which we then pass to the say hello function. In the case that it's successful, we return a status code of 200 with the string output mapped into the body. And then, in the case that this exception type is thrown, we're going to serialize that, put it in the body, but now we're going to turn 400 like we said. And so, and then, last but not least, we'll wrap this all up in a shelf server and start listening, on a TCP port. And so we're making progress. And in fact, when you run Celest start or Celest deploy, everything we just talked about is what happens in those first couple seconds. And in the case of Celest start, it's going to take that HTTP server that we generated, it'll spin it up locally on your machine, and then set up a file watcher so that anytime anything changes, it can hot reload those changes into the running server. In the case of Celest deploy, it gets a bit more complicated. We're really just getting started in that journey. So I'm all out of time for this talk, but if you do want to hear that side of the story, please let me know. You can let us know on X or just ping me wherever. I'd be happy to share the rest of it. And yeah, if you haven't tried Celest and you're curious to do so, you can head over to celest.dev, download our CLI, and you can get that first project spun up in just a few minutes. So thank you.